Hello, everybody. Hey, this is going to be the video for week one review 4. Now we're still dealing with these same sort of equations, except now we're going to talk about throwing something up and down or just dropping it. So when we go up and down, we're obviously talking about gravity. Okay, so just like review number 3, we're going to have these same equations. We're going to have these same equations, but when we're moving up and down, okay, we always know what our acceleration is. Okay, and our acceleration, okay, is going to be the acceleration due to gravity. The acceleration due to gravity, which we call g. Okay, so now we are going to that acceleration is going to be 10 meters per second squared. So how do you know when your acceleration is g? And when you're looking in those problems, when you're looking for words like drop or throw or shoot or launch or project, kick, all those sorts of things are going to suggest that an object is in free fall. Okay, so that means this doesn't have, let's say, a rocket or an engine on it. It's just falling. Okay, so that is the first part. Okay, and usually when we're going up and down, we'll call the distance height, and instead of calling it x and y, we will call it or instead of calling it x, we'll call it y. Okay, but it's really still the same thing. So if we look over to our 4 equations here, we're going to change a couple things here. So this is going to be GH. That's going to be GH. This one over here is going to be H. And this one's going to be G. And this one right here is going to be G. And this one right here is going to be H. Okay, so we can see, you guys, we can see it is the same pattern. We can see it's the same pattern as we had before. We're just talking about up and down as opposed to left and right. So, and we also going to have to change these. So this, there is no G, and here is, there is no H. So you can certainly don't have to rememorize those equations there. You just know if it's in free fall, your acceleration is 10. And that 10 is always down, and then height is whatever. So what can help is if we think of h being up is always positive, that can kind of help us. That can kind of help us answer these questions. All right. So a couple other things, as you can, if you're reading in there, if I throw something up with a velocity of, let's say, 10 meters per second, and I throw it up, gravity is slowing it down and slowing it down and slowing it down. So at a certain point, it's going to reach its maximum height. And that maximum height, the velocity is 0. So at the top of the arc in the up and down direction, that velocity is 0. Okay. And now gravity is making it go faster and faster. So when it comes down, so if it reaches the same level, instead of, it's going to have the same speed, which is 10, except the direction is going to be negative. So its velocity would be negative 10. So if it starts out as being positive 10, and then it comes back down to the same level, it's going to be negative 10. Okay. But gravity is going to be the same the entire time. So if I throw an object up and it reaches its highest point, its gravity is still 10 meters per second down. But just because it stopped doesn't mean that gravity disappeared. Okay? All right, let's take a look at a few questions. All right, for question number 1, a man drops a ball off of a cliff that's 9 meters high. Now, what can kind of help when we're doing problems is to draw a picture. Okay? So we've got a ball right here, and it's dropping 9 meters. Like so. And what is the ball's velocity? What is the ball's velocity when it hits the ground? So unlike review number 3, where I told you you needed 3 variables, now essentially you only need 2 variables because you always know that gravity is 10 meters per second squared. So in this case, if we are if we're talking about our variables that are given, we're talking about height. And we're really talking about -9 meters, because if it starts here and goes here, it's going to go down negative. And this G is going down, and that is going to be negative. And because we drop it, our velocity is 0. Okay. Now, we also, again, this is the hard part. We want to try to identify which of those 4 equations we're going to use. So we want to look at, now we want to know V final. Okay. So equation number 1 has V final. Equation number 2 has V final. Equation number 3 does not have V final, so we're not going to use equation 3. We are not, let me see, we are not given time, okay? So it looks like we're going to use equation number 4. Okay, so we can now say V final squared is equal to V initial squared plus 2GH. Okay, so again, we're following the same pattern that we did in yesterday's review. Okay, and so V final is what we're looking for. Our initial velocity is 0 because it got dropped. So 0 squared is just going to go away. Plus, we're going to have 2 times 10 times 9. 2 times 10 times 9. And that is going to be equal to 180. And that's actually going to be meters per second squared times meters, which is going to be meters squared per second squared, and that's going to be V final squared. So if we're looking for V final, we need to take the square root, okay? So if we take the square root of both sides, okay, the square root of V final squared, that part's going to go out. So V final. And now we're going to look at the math here, okay? And we're going to take the square root of 180, and that's going to give us 13.4, okay? So our answer is 13.4 meters per second. Now, here is something. If we drop the object here, that velocity is going to be hitting the ground, and it's going to be going in the negative direction, right? So really, this should be negative 13.4. Now remember, when you take the square root of something, we usually just look at our calculator and it's positive, right? But it can also be negative, because 2 times 2 is 4, but negative 2 times negative 2 is also positive 4. So anyways, this is our answer. This is our answer to the first question there, all right? So let's take a look at the second question. And that second question is, how long does it take for a rock dropped off a building to reach a speed of 10 meters per second? Okay, so if we look here, I'm going to kind of erase this first part here. And this is really kind of a similar question here. Because since it's dropped, its acceleration is going to be due to gravity, which is -10. And since it's dropped, its initial velocity is still 0. Now we want to know what is its time before it reaches 10 meters per second. So now we know what the final velocity is, and now we're looking for time. So we don't have h there, okay? So we can't use equation number 1 because that's got an h, but number 2 doesn't have h, and we can't use number 3 and number 4 because they all have h's, so we're going to use equation number 2. So we're going to say V final is equal to V initial plus GT. okay, plus gt. So we know that this is 0 because the initial velocity is 0. We dropped it. We know that our final velocity is 10 because the question said that. And we know that gravity is going to be 10 meters per second squared. Now, this is going to be negative 10 because it's going down. But this is also negative 10 because the velocity would be going down. Now, we can think of down as positive, and you can if you want. But we can see that this is going to go away, and this negative and this negative are going to cancel out. Oh, we forgot t. And to get rid of this t, we're going to divide by 10 meters per second squared. 10 meters per second squared. This is going to drop away. So t is going to equal 10 divided by 10 is 1. Meters per second divided by meters per second squared is just going to be seconds on the top. Okay, so the answer is it's going to take 1 second for it to reach a speed of 10 meters per second. Okay, and there we have it. Okay. So now our third question here, again, look at that, and it says, how long does it take for a dropped object to fall 16 meters? How long does it take for a dropped object to drop 15 meters? Okay, so we know that our initial velocity is 0 because we dropped it. We know because it's dropping, its acceleration is negative 10 meters per second. And now we know the height. We know the height is going to be 16. Okay, but because it dropped, okay, it actually went negative 16 meters. Okay, and we this time want to know what the time is. And let me see, we don't have v final, so we can't use equation 3, and we can't use equation number 4, and we can't use, we can't use equation number 2, and we can't use 4, and we can't use 1, so we have to use equation number 3. And again, that's the tricky part, is figuring out which equation we can't use. All right, so we want equation number 3. So h is equal to VIT plus 1/2 GT squared. Okay? So right here, our height is going to be negative 16 meters. Our initial velocity is 0 because we dropped it, so that's going to go away. And then we're going to have 1/2 of 10. And that's really 1/2 negative 10, okay? And that is going to be t squared, okay? So we're going to multiply both sides by 2, and that's going to get rid of the half. And then we're going to divide both sides by negative 10, and that's going to get rid of that. So 2 times negative 16 is negative 32 divided by negative 10 is equal to, the negatives cancel out, which is going to be 3.2, and that's equal to t squared, okay? So now all we have to do is to take the square root, of both sides, and 32 divided by 10, take the square root, and we're going to get 1.788. So we're going to call that 1.8 seconds. So our time is equal to 1.8 seconds. All right, so that is kind of the basics of things when we drop or throw or shoot something. And we've talked about things going just straight up and down. So I hope that helps. There's going to be 3 more problems there for you guys to do. Thanks, and we'll see you guys next time.